5.5 is function operations. Looking at the basics of how we work with functions. How do we add and subtract them? How do we multiply? How do we divide? And then on the back side, we'll be looking at function compositions and what all that entails. The other thing as we go along, this homework does ask some domain questions, so we'll also be reviewing and talking about domain with those. Now, when we're talking about functions, these functions are usually represented as f of x or g of x or h of x or whatever the case is. Okay, but we're going to start very basic. How do we add functions or add and subtract functions? So as we look at example A, let f of x equal 3x plus 4, and g of x is x squared minus 5x plus 2. And we're asked to perform each function operation and then find the domain. Okay? So don't forget domain. We'll come back and talk about that in a moment. But very basic, guys. F of x plus g of x. How do you think we add f of x plus g of x? Okay. So what is f of x? F of x is 3x plus 4. And then it says to add g of x. So what is g of x? X squared minus 5x plus 2. How do I clean that up? Yeah, combining like terms, right? So if I go for highest power to lowest power, not that you necessarily have to unless it says, but my highest power is the x squared term, right? I only have one x squared term, so I'm just going to say x squared. Then x's. What do I have in the way of x's I can put together? Yeah, 3x minus 5x is going to be minus 2x. Or I should say 3x plus negative 5x, I guess. And then, in terms of constants, we have 4 plus 2, which is 6. Okay. Given two basic functions, you're asked to add them, just put the like terms together. Okay, nothing fancy here. Before I move on, one of the questions I was asked also was domain. Now, first of all, what do I mean when I say domain? Domain are the what type of values? The x values, right? So the domain values, my x values, my input values. What type of values can I put into this equation or this expression and it still be okay? Okay, in other words, are there any values, so if we look at f, are there any types of numbers that I can't multiply by 3 and add 4 to? In other words, can I put positives in here? Yeah, I can multiply positives by 3 and add 4. Can I put negatives in here? Yeah, okay. This is just basic multiply and add, subtract. You can put any number in you want, right? Same thing true for g. Yeah, I can take any number I want. I can square it. I can multiply by 5 and subtract it. I can add 2 to it. I can do this with any number I want. So with these types of problems where it's just terms being added and subtracted, my domain is going to be all real numbers. Okay. Domain here is just all real numbers, meaning I can put 0 in. I can put negatives in. I can put decimals in. There's nothing I can't put in. Okay? And I'll tell you, at the beginning, it's going to be a lot of all real numbers. As we get farther on, and maybe we run into a fraction, where the bottom of fraction can't equal 0, or a square root, where you can't have negatives inside of a square root, then we might have to change things up. But unless you have any of those extra things going on, it's just going to be all real numbers. Your in homework, I believe they do the domain as multiple choice. And like all your multiple choice answers will start all real numbers. And there'll be one that is just all real numbers. And there'll be one that's maybe all real numbers except x equals 0. All real numbers except x greater than 0. Or, there'll be some things like that. But in this case, we're just looking for all real numbers. Anything works. Okay? Part B asks us to subtract f of x minus g of x. Well, what is f? 3x plus 4, and then we are what? We are subtracting g of x. So I'm going to subtract, and g of x is x squared minus 5x plus 2. Notice, what did I do with g of x, though? I put it in parentheses, right? And that's indicating that I'm subtracting every term. Okay? So be careful there. You can go ahead and do the math, or if we write this out, it's 3x plus 4, and we're going to be what? We're going to be subtracting x squared, so minus x squared. We're going to be subtracting negative 5x. What does it mean to subtract negative 5x? We're going to actually be adding 5x. And then, as I said, you think of this as distribute, we're going to be subtracting 2. Now put together your like terms, yes? What comes first? Or what can come first, I guess? This time it's a negative x squared, because there's no x squared to begin with, and now we're subtracting it from nothing. What about my x's? 3x plus 5x is 8x, and then 4 minus 2 is 2. So here when you subtract them, you end up with negative x squared plus 8x plus 2. And then we need to ask the domain question again. Thoughts on domain? Huh? All real numbers. And the question becomes, is there anything I can't put in? No, it's the same f and g from earlier, yes? The only difference is I subtracted instead of added them, so my answer looks slightly different, but it's still doing the same type of operation. I can take any type of number I need to and put them in. So my domain here is, again, all real numbers. When we eventually get something that's not all real numbers, it'll hopefully start to make a little more sense if that's a little confusing to you. Okay? If there's not questions, let's try B. Notice B gives us f and g again, but it's a different f and g, yes? Don't go through a whole assignment thinking f stays the same the whole way. It changes. Okay? F will be assigned differently. So this time we have a new f and a new g. And again on A, we are adding. Let me show you something though. Notice on the first A up above, it was f of x plus g of x, yes? This is asking us, this A is asking us to do the same thing. It's just slightly different notation. So this is still saying f of x plus g of x. But a different way you might see them write it is you might see them say, okay, f plus g of x. However, as I said, this is still f of x plus g of x. So don't try and do anything fancy. You're still just adding those two functions. So looking for your like terms and adding. So if I check this out, let's see. F is 2x squared plus 7x minus 1 plus g is, g of x is 3 minus 2x. Put your like terms together, yes? What do I have here? First term I would choose to write would be 2x squared. I just happen not to have any other x squareds to go with it. 7x goes with minus 2x, and you have 5x. Minus 1 goes with plus 3, and minus 1 plus 3 is plus 2. So 2x squared plus 5x plus 2. And Before we move on to the second part, domain. Are there any values we need to exclude? Now, this is similar to the last problem, right? We've just got a basic polynomial where we've got terms added and subtracted. So domain again is all real numbers. Okay. B. What changes up on B? Yeah. My order changed up. Does it matter? For subtraction, it does, yes? If it was adding, it's whatever. It doesn't matter which order we add in. But it does matter when you subtract. So realize as you write this out, you're doing g of x minus f of x. So you need to make sure you write g first. So 3 minus 2x minus the 2x squared plus 7x minus 1. If you're talented enough, feel free to write your answer from there. If you need to write that extra line, then do it. Okay, so if I write that extra line, it's still 3 minus 2x. And we're going to be subtracting 2x squared, subtracting a positive 7x, so subtracting 7x, and subtracting negative 1 means I'm actually going to be adding 1. Okay. What you got here? Okay. Negative 2x squared is my only squared term. Minus 9x, because we have a minus 2x and we're subtracting 7x. And plus 4, because we have a plus 3 and minus negative 1, which is plus 1. So negative 2x squared minus 9x plus 4. Domain? All real numbers? No exceptions. Okay, anything can go in there. Okay, got it? Okay, adding, subtracting, pretty basic. Look for like terms, put them together. Next section, we're going to multiply. And as we practice this multiplication, we're going to put them in a few word problems here. And the book uses a revenue situation to talk about the multiplying. What's revenue? Do we know what revenue is? What? Yeah, how much you make. Okay. In a way, it's your income, but it's not just your income because it's, as a business, it's not just your income, it's how much you're making, right? After you cover your basic expenses and everything, what are you making there? Okay, so kind of, or maybe it's just what you bring in, because profit would be what you make once you cover your expenses. But the idea of, your sales. Now, you will notice there, okay, key piece to be familiar with is that revenue is to be defined to be price times the demand. So what you bring in is going to be defined by the price of the object, the price that you sell the object at, times the demand for the object. Okay, so keep that in mind. And let's look at example A. the demand D in units sold for a company's new brand of a cell phone at price X in dollars is given as D of X equals 5,000 minus 10X. What is the company's expected revenue from cell phone sales in terms of the price X? Then state the domain of the function. And then if the price is 200, how much revenue will the company earn? So I don't know if you see it, but there's 3 questions we're going to be answering here. What is the company's expected revenue? We're going to be asked about domain. And then if the price is 200, how much is revenue? Okay. How do we find revenue? Okay, price times demand. Were we given a price and demand? Hopefully. Otherwise, we're going to really struggle to do this problem, aren't we? What do you see? Okay, demand is D of X, which is 5,000 minus 10X, right? So demand is a given function. What about price? Were we given price information? Yeah, it's there if you read. Price X, yes? So demand is D, which we're given a function, and price is X. So in order to find revenue, I'm going to write it as R of X, which stands for revenue, of course. Now we're doing price times demand. The price was what? X times the demand, which is 5,000 minus 10X. Okay. Can we clean this up a little bit? Can you multiply? Distribute? So if we multiply, X times 5,000 is 5,000X minus X times 10X, 10X squared. And I assume you have to put it in multiplied form. I guess I honestly can't say for sure. I know I tried some of the homework problems, and I remember doing this, and I put it in multiplied out form. I don't know if they would accept it otherwise or not. But that right there, that is what is the company's expected revenue in terms of X. So this is the company's expected revenue. Okay? Let me get the other easy one out of the way. How do I find if the price is $200, how much will revenue be? How do I find that? Yeah, plug in 200 for the price, right? So that means, if you will, I'm going to say we're finding R of 200. And that's just indicating that I'm going to put 200 in for X. So 5,000 times 200 minus 10 times 200 squared. Do the math. You can either try your luck with using your brain, or you can grab your calculator, right? The math is not that hard. There's just a lot of zeros. That's the problem. Let me know when you get an answer. What'd you get, Mara? Uh-huh. Sounds like the price I was expecting to hear. 600,000. Or you don't miss input any zeros or anything silly like that, right? Okay, yeah. Should be getting 600,000. And we have one other piece here. We're asked to find the domain. Now, we're going to have to think a little bit on domain here. Let me state my question like this. Why is my domain not all real numbers? Okay, can we have negatives? No, right there we have to stop and say, oh wait, this has to be a little different, doesn't it? Okay, we can't have negatives. So, one thing is, if we think about the price, our price was represented as X, yes? Can the price be negative? No. Your price is going to have to be a positive value. And so my price, there's going to be two parts to this, so bear with me here. But one thing is my price is going to have to be positive, yes? Now, I'm using X greater than or equal to 0 because that's what they used in the book. Technically, I don't really want to put the equal to on there because could the price really be 0? I don't know, I guess it could, but it doesn't really make logical sense, does it? So I would personally have just said X greater than 0, but they said X greater than or equal to 0. Close enough, but the price has to be positive, yes? And what about the demand? Can we have a negative demand? Doesn't really make sense, does it? Okay. And so for that purpose, we also need to consider the fact that the demand needs to be positive. Now, what was our demand? Our demand was 5,000 minus 10x, and that needs to be positive. Now, when I'm saying positive, I'm saying greater than or equal to 0. Can you solve this with me so we can get an actual number here? If demand has to be positive, 5,000 minus 10x is greater than or equal to 0, how do you solve that? What's an option? Okay. One option would be to add the 10x over. That means you're trying to avoid negatives, aren't you? What's the other option? Subtract 5,000 over. And for my own personal reason, I'm going to subtract 5,000. I totally understand the going positive, though. But I want to address an issue, so I don't care if you add 10x or subtract 5,000. We'll get to the same answer. Okay? I just have my reasoning for going this way. So if I subtract the 5,000 over, I have negative 10x greater than or equal to, and 0 minus 5,000 is going to be negative 5,000, yes? And this is why I agree. It would be so much better to be positive right now. But how do I solve for x? Okay. In my case, I'm going to divide by negative 10. If you went the other way, you're dividing by positive 10, yes? Negative 10x divided by negative 10 is x. Negative 5,000 divided by negative 10. $500. What's the catch? Why did I choose to come this way?
Because you don't have to switch your sign.
Well, what do we do when we divide both sides by a negative? When you multiply or divide both sides by a negative, we have to flip the sign. So this greater than or equal to becomes less than or equal to. If you went the other way, and I'll just do a side note down here, you had 5,000 greater than or equal to 10x. You divide by 10, you have 500 greater than or equal to x, but guess what? When you flip that around, you have this right here, don't you? Okay? So the way I wanted to mention the fact that, don't forget, when you divide by a negative, you have to reverse the sign. If you set up so you didn't have a negative, that's fine. Just flip your answer now. Okay? Now, we had two pieces here, yes? we have to put this as a final domain answer. My price had to be positive, so greater than or equal to 0. My demand had to be positive, so greater than or equal to 0, resulted in what? X has to be smaller than 500, right? So my price has to be bigger than 0, less than 500 for this to work. So my domain, when I write that, I'm going to write it as 0, less than or equal to X, less than or equal to 500. And I believe that is how they were expressing it in homework. The idea that your domain is something between 0 and 500. Okay? Because the price has to be positive, bigger than 0. But the price, in order for this to work with demand and everything, the price has to be less than 500. Okay? Questions on that? Okay. Obviously, domain is going to change up a little bit when you put it more into real-world situations. Okay? And morning class asked, realize there are people out in the business world doing this on the backside of things, right? Exactly this? Not necessarily, but are they trying to figure out the best price to sell something to make the most revenue, to make the most profit? Yes, they are. Okay? There's someone out there on the backside doing this. So, not exactly these formulas or anything, but the same gist. Okay. Next one. I think the next one we just have one question, if I recall. Yeah. Suppose demand D for a company's product at cost X is predicted by the function D of X, negative 2500 X squared plus 1000, and the price P that the company can charge for the product is given by P of X, X plus 16. Find the company's revenue function. How am I going to find revenue? Price times demand. It says it right there, doesn't it? So price times demand. And if you want, I can say P of X times D of X. What is my price? X plus 16. Times, what is my demand?
Negative 0.25 X squared plus 1000.
Negative 2500 X squared plus 1000. Now, I guess there's a chance Savas will let you leave it like this. Probably not, though. How do we clean this up? Distribute, multiply, FOIL. And actually, considering the whole point of this is multiplying, they're probably not going to let you leave it like this now that I think about it. So, X times negative 2500 X squared is going to be negative 2500 X cubed. X times 1000. 1000x, then distribute the 16. 16 times negative 2500 X squared. Negative 4. So that's going to be minus 4x squared. 16 times 1000. 16,000. And can I clean that up anymore? Not really. There's no like terms. If it forced you to, you could possibly rearrange them highest power to lowest power. As far as I'm concerned, there's not an advantage where you have to do that right now unless it says to. And this is what they want. It said find the company's revenue function. Guess what this is? This is their function representing revenue. So that is the revenue function there. Okay. So multiplying, but also talking a little bit about revenue there. We've added, we've subtracted, we've multiplied, so guess what? What else is left to do? We've got to divide, right? Okay. The backside, which is what we'll definitely get to tomorrow, is composing functions. So that's f of g of x, g of f of x. I sometimes call them Fogg and Goff. We'll talk about that tomorrow. But we're going to talk about dividing right now. And similar to the top section, given f, given g, find this is f over g of x. And then we're also going to have to talk about domain. So first of all, realize, again, different forms, f of g or f over g of x. Realize they're wanting you to do f of x divided by g of x. Yes? So, set it up. What is f of x? X minus 7. Over, what is g of x? 2x squared minus 13x minus 7. Okay. Now the key is, do I get to leave it or does it simplify? Okay. I guess if we really wanted to do something crazy, we could try something like long division. Wouldn't work out very well for us. It wouldn't be very fun either. However, I'm also going to tell you, if you try and put this answer right into Savas right now, it's going to tell you, while this is equivalent to the correct answer, it is not in simplest form. Okay? That dreaded answer that we always hate to get, right? Now, options. I guess I should address the fact, can I cancel those 7s? We talked about this right before Christmas, right? You can't cancel the 7s, can you? We can't cancel pieces that are added and subtracted together. Okay, that was November, December, we talked about that. Okay, instead we need factors to cancel. So if there's anything that factors, or we can cancel factors, that's what's going to cancel. Now, I'm going to show you a couple of different ways to think about this. On top, we have x minus 7. Does x minus 7 factor? No, x minus 7 is just, it is as it is. 2x squared minus 13x minus 7. What would you guess that's going to look like as a factor? It's probably going to look as 2 parentheses, right? And especially if I've already told you this does simplify, then this is going to look like this in 2 parentheses. What's the catch? What's the catch with these 2 parentheses here? Product of AC, because this isn't just x squared, is it? This is 2x squared. Now, if this was x squared, what would I suggest? And I'm going to show you a way that technically you can do this without product of AC if you like it. If you don't, I'm going to show product of AC here in a moment too. Okay? I'm going to show some options. But 2x squared. It's not going to be x times x, is it? But what would it have to be instead? There's only one other way to get 2x squared based on this type of setup. And instead of x times x, it would have to be 2x times x. Logical? Okay? Now, with that in mind, and with the fact that I've already told you something's going to cancel here, okay, my first terms have to multiply to be 2x squared. What do the last terms have to multiply to be? 7. What's the only way to multiply to be 7? 7 times 1, yes? Now, if we take a guess, and it's a guess, should I put it as 7 and 1? Or 1 then 7? And why would you guess 1 and 7? What are you seeing here?
The first parentheses has a 2 by the x, and the second parentheses has a second parentheses.
Yeah. If there's an x minus 7 on top, is it likely that there might be an x minus 7 on bottom? If something cancels, yes. And I'm telling you right now, Savas has already given me the wrong answer, or the answer of, well, this is correct in the final answer. This is not it. It's not simplified. So that's my logic here. Now, here's the other piece of this. How do you multiply? What kind of 7 do we need? We need a negative 7. How do you multiply to get a negative 7? A negative is a positive and a negative. So you want positive negative or negative positive? Again, this is a guess that that's going to be the negative, thus forcing the positive over here. Now, can you check yourself without doing product of AC right here? Yeah. Let's check ourselves. And I can check myself, does this FOIL to be this right here? So 2x times x is 2x squared, okay? 2x times negative 7 is negative 14x. And 1 times x is 1x. What's negative 14x plus 1x? Negative 13x. 1 times negative 7? Negative 7. Did that check? Yes. Now, do all of you like that? Probably not. Okay? If you see it, it works great because what can happen here? X minus 7 can cancel with x minus 7. And what remains? What remains for an answer here? Yeah. Everything cancels on top, so that leaves the invisible 1. 2x plus 1 on bottom. That would be your final answer because of canceling. Now, I don't feel like I'm doing my job if I don't take a moment and review product of AC. Because some of you are going like, Mrs. Sargent, no, I don't like that. I have pre-calc and calc kids that I try and teach that, and they're like, no, I don't like it. I like my product of AC. Okay, product of AC, here we go for a review. 2x squared minus 13x minus 7. Do you remember this at all? We did a lot first semester. Product of AC is product of 2 times negative 7, which is negative 14. And a sum of what? The middle term, which is negative 13. What multiplies to be negative 14 and adds to be negative 13? I mean, my choices are 1 and 14 or 2 and 7, yes? How am I going to get that sum of 13? I have to use the 1 and 14. I'm going to say positive 1, negative 14. What do I do with that positive 1, negative 14? We split them. Is this coming back at all? Okay. So drop the initial term of 2x squared. Just carry it down. Minus 13x. I'm going to use that plus 1 minus 14. I think I'm going to go ahead and say minus 14x plus 1x. And then bring down the minus 7. 4 terms. How do we factor with 4 terms? Split it in half, right? GCF of the first half. GCF of 2x squared minus 14x. 2x. Factor out the 2x, and we're left with x minus 7. GCF of 1x minus 7. If all else fails, just a 1. It's a positive 1. If you divide by 1, we're left with still x minus 7. 2 parentheses here. 1 parenthesis is your GCF of 2x plus 1. The other parenthesis is the matching x minus 7s. Is that what I got over here earlier? It is, isn't it? Oops. So, I don't care. Product of AC, or if you want to try some guess and check, that's fine. There's some clues to help us, yes? Now, before I can finish up, what was the other thing asked for today? Domain. There's a catch. Okay? So with the domain, if you just look at F and G, All real numbers work, don't they? Okay, guys, there's a fraction. We talked about this back in chapter 4. We did this before Christmas. I'm going to say all real numbers except, and then there's two values I have to give. All real numbers except what? What can x not equal? Do you remember doing this? We called them excluded values or restrictions on the variables. Oh no. Set each part equal to 0. So 2x plus 1 equals 0 and x minus 7 equals 0. We cannot have 0 in the denominator here.
Please come to the high school office. Bring Haluka to the high school office.
So I'll have this up here tomorrow. X cannot equal negative 1/2 and 7. So I'm going to say all real numbers except x equals those two. And we'll finish this tomorrow.
I know.